Hello, and welcome to episode 214 of Quarkus Insights. We've got a special guest of Guillaume Smet, and we're going to be talking about Quarkus and build reproducibility. Are we there yet? And before we start anything, I have to say, I think this is my favorite episode title for a long time.
Yeah, so the good news is that we can just answer no,
Yeah,
and then go
done.
to the beach. And yeah, but yeah, that's
Yeah, but before we go to the beach, we can do the news. So let's talk about. We were just talking about before we started. We were just talking about the news, and I asked Guillaume what the news was, and we were almost late starting because I got so much news. So what's been happening?
So we released Quarkus 3.25. Unfortunately, we had a couple of regressions, typically in the CLI and a few other things. So we are working on fixing them, and hopefully 3.25.1 will fix the most prominent issues. And in other news, we are working on preparing 3.26 and finalizing 3.26 because 3.26 will be the base for our next LTS release, which will be 3.27 that we plan to release at the end of September. So we have a feature freeze on August 13th, and we are all on deck to try to finalize everything before.
So 3.25 was the right timing for us to break everything, so
yes,
we can fix it before 3.26.
Yes. Well, I would say that there are no ideal time to break anything, but
that's just such a boring attitude.
Yeah, I know.
It's that sort of, emphasis on quality that. But yes, I know what you mean. But so speaking of emphasis on quality, that's probably a good sort of segue into the topic for today, which is reproducible builds. So I guess before we start, can you tell us what a reproducible build is and why anybody would want one?
Yeah, so it's not a new concept. It has started becoming a thing several years ago. And it has been quite popular in the Java ecosystem lately. And when I mean lately, I mean the past few years. The idea is that coming from a known set of source files, meaning you have your tag, you should be able to build your application and make sure that the result is exactly the same than the one you had the previous time. So you can do 10 builds of the exact same bits, and you should have the exact same result. The idea is that this way you can make sure that your binaries have not been tampered and that they are exactly what you would expect from the source. The other nice outcome is that if you actually want to compare the binaries and you have a weird behavior and you actually want to compare the binaries, you will have a very minimal changes because everything that is changed will be exactly what has changed and not some noise generated by your actual build. For most applications, meaning that when you just build a jar, it's usually very simple because all the tooling ecosystem has evolved a lot in the previous year, and you will have typically the meta-inf will be generated in a reproducible way, so you won't have issue with the manifest, for instance. Your jar will also be properly ordered. Typically, when you're talking about build reproducibility, you have to understand that even adding files in another order into your archive, your jar or a zip file, will end up with a different binary. So you have to be careful to properly order things, add things in the proper order, and all the tooling is now designed to end up with reproducible builds. And in your typical Java application, what you do is you have a project built output timestamp property that you can set, and you set it to a fixed value that is updated by the Maven release plugin when you release. So when you release, you set this value once and for all, and it will make sure that in the zip, all the timestamps of the added files are exactly the one that you define in your POM file. Meaning that because even if just the date of the file in the zip changes, then your zip is not exactly the same and your binary is not exactly the same. So if you want the exact output, everything from the permission to the date, to the metadata, to the order of, even if you have some metadata file in your jar, you don't really care about the order. It's basically a set of things. You need it to be properly ordered and make sure that the order will be reproducible for every build. And when I mean every build, it's not one build out of 10. It's like every build, which makes things a lot more complex. And so I would say that for most of your simple libraries, if you have a simple Java library at the moment, if you use a project build output timestamp in your POM file, then you will end up with a reproducible jar. Things get more complex with Quarkus because we have our own format for applications. We generate what we are calling a fast jar, which is actually a directory. We generate code. We generate a lot of code. We generate specific metadata files that we include in the jars. And so that for Quarkus, there is a lot of work to do. And in two areas. The first area is that we wanted the Quarkus build to be reproducible, meaning that when you build the Quarkus extensions, the Quarkus jar, the Quarkus jars, you want them to be reproducible. So we had to tweak a few things, but this was a simple part. And then you have to also fix the issue of you are generating a Quarkus app, you need the output to be fully reproducible.
And I think you've perhaps partly answered sort of a backwards question that I was going to ask, which is, our industry is 70 years old. And so why did we only start caring about reproducible builds a few years ago?
We were quite lucky before, meaning that we weren't so cautious maybe about security because there were a lot less attack vectors, things like that. And nowadays, you want to be absolutely sure that what you run hasn't changed and hasn't been tampered. And it's vital, it's crucial, and that's so. I wouldn't say that nobody was thinking about reproducible builds before. It has always been a subject, and some people were actually trying hard to make sure that their builds were reproducible. But it has become very common in the industry, I think mostly because of the security and all the supply chain issues that we have seen for, 10 years, maybe a bit more now. And we are a lot more cautious about the supply chain nowadays.
Yeah, makes sense. And so for Quarkus, you sort of said that so for the Quarkus builds itself, is that now completely sorted and completely reproducible?
So, the funny thing is that it's not a new subject for Quarkus either. Peter Palaga, who is working on CXF and Camel Quarkus, actually created a few patches back in 2020. So it's really not a new subject. And back in the time, people from the team said, oh, I was actually kinda interested in the patches because, to be honest, if it was just me, our build would be exactly done in order, and we would add a lot of constraints everywhere to make sure that everything is always fully deterministic. It has a cost, because when you are using deterministic data structures, it's more costly, both to add the items, but also to get them, check if they are there and things like that. So when you are talking about a massive build, it comes at a cost, but still it's very, for me, being deterministic has its advantages. Anyway, at that time, we sort of pushed back saying that, oh, yeah, it would require a lot more things to actually be reproducible. And we were right. But still, it was the first steps, and part of the work I'm doing today is based on some of the early patches of Peter. So he had a patch to actually sort the build steps. We will talk about that a bit later, that I'm using. And I also built on top of some of his other patches, or just the fact that he had created a specific patch for an area led me to the conclusion that we needed to make some work in this particular area. And even if I didn't use the exact same patch, it was still a big part of what led me to this effort. So I wanted to say thanks to Peter for starting this conversation 5 years ago. And we are now continuing it today, and
do you think we might see some functional benefits as well? Like, I'm just thinking about the build steps, and if we have more determinism in that area, do you think it will slightly reduce the occurrence of Heisenbugs, where just that slight non-determinism means that the behavior itself becomes harder to reproduce of the built artifact?
Yeah, so that's an interesting question, and I think we should go back to it in a few, because I wanted to talk a bit about the tooling that we are using. So the tooling, as I said, has evolved a lot, and so for the simple checks that you can do for simple libraries, you have the Maven artifact plugin that has a goal to check the reproducibility of a build. So it will use 2 builds and check that they are reproducible. This is not something that you can use for a Quarkus app yet, because it's a directory that is specific. It's not attached as an artifact. So we don't have the tooling for a Quarkus app yet. And the other tool that we are using is called Diffoscope. So this is amazing. You point a big directory to it, and it will go through all the jars, all the files, find the differences. It will unzip the zips, the jars, go into each file. It can decompile the Java file. So when it finds the differences, it will decompile the files and let you know what are the differences. I will show you a few examples later. But it's, I mean, it's not even, I think the journey would have been so much more painful if I didn't have this very simple targeted tool. But the fact that it can decompile the classes is extremely, extremely useful. So this is, this is what we are using, plus a couple of a couple of scripts to be able to simplify things and run several builds and then compare the results and check the output in the browser. That's basically what we are doing to iterate. For Quarkus itself, it was relatively simple until you end up with the CLI, because the CLI is actually a Quarkus application. It's an Uber jar, which is a Quarkus application. So to actually get the Quarkus, the full Quarkus build reproducible, you actually have to solve the fact that building a Quarkus app needs to be reproducible. But if we just talk about the extensions and the extension ecosystem, it was actually quite simple. It was more, so we are generating a couple of metadata files when we are creating an extension, and they were not reproducible. The order of things weren't reproducible. Typically, if you use Jackson to serialize things, except if you pass the options to order the entries, it's a big hash map. So sometimes you get the same order and sometimes not. One of the problems is when sometimes you get the same output because you test things, oh, it's working well, and then you iterate and, oh no, it's failing again. And so that's one of that's why it was extremely iterative, because yeah, you think it's sorted out, and then 10 builds later you discover that oh no, I still have an issue. But it only happens 1 out of 10 builds, so it's harder to reproduce. And that's one of the difficulties, that even if at the end I'm able to get a reproducible build, I'm not able to prove it. I typically at the moment, so I'm iterating on a small Quarkus app with just the REST extension. So it's a simple REST app. And most of the time I have the same binary, but from time to time, I don't. And
yeah, I mean, it's sort of a more general problem with hash maps, isn't it? Because I've had this with like a whole bunch of other things where it's deceptive how deterministic hash maps are, because you think, oh, it's a hash map, it's not deterministic. But actually, on the same operating system with the same JVM, it actually tends to be fairly deterministic. And so then it's only when we try like a different operating system or a subtly different JVM, or like in some of our CIs, we see it with a different cloud provider, and it should be exactly the same. And then something about that GitHub runner means that the hash map does things in a different order, and you realize that you had an ordering dependency that you didn't know.
Yeah, actually, I don't remember which data structure. It's something that Johan discovered at some point, but for one data structure in the DVM, they're actually making sure with specific code that it's random. So they are making sure that this data structure is random, so that you will always have some sort of different output from one run to another. And but yeah, for hash maps, it can be, yeah, you have your ops I, and then oh no, again. So everything, so you have to the time zone, yeah, and yeah, what's important, and you were talking about it, is that it needs to be reproducible on your machine, but it's also need to be reproducible on any machine, meaning that it needs to be reproducible on Linux, on Windows, and you need the same output on both. On a weird architecture also, I had an issue with file sorting on Windows and Linux, because sorting files on both, if you sort on, if you have a list of paths, I'm talking about the NIO ones, and you sort them, and you have uppercase, lowercase,
yeah,
the order won't be the same on Windows and Linux. So you have to fix that to make sure that the output is the same on both OS, and that's yeah, that's what makes it a bit hard. So some things are simple to fix. You just have a descriptor file that is not properly ordered, so you just make sure that they are ordered. And then there are a lot of other problems that are a lot harder.
Like that case one is so tricky because there's not very often in Java that you're going to end up with the same artifact with different case names because Java is so opinionated about cases.
Yeah.
But it will happen sometimes, and then
exactly.
Yeah.
And in the if you typically you have the meta-inf, which is uppercased. You have there are part of the files that are actually uppercase, lowercase, and yeah, if you so the thing is that when we will finally have some CI checks to check that we are on the right way, we will have to build the binaries on Linux, on Windows, on Mac OS, get all of them, and figure out if there are differences between all of them generated on all these different architectures. That's only this way that we can be relatively sure that our binaries are the same. It's yeah, so it's a journey really, and so the Quarkus itself, meaning our extension, it was relatively easy to solve. But then started having a look at Quarkus apps, and this is where the fun begins, because so we have our own format. We generate our own jars for our default format. We have this Quarkus run jar. We have the bytecode generated that is in a specific jar. And all of this, we need all the jars to be sorted, which wasn't the case before. We need so when you add the transform classes to the jar, you need to do it in a proper order. Basically, every basic operations needs to be properly sorted. We needed to also propagate the project built out timestamp that I talked about earlier. It's used by default by the Maven jar plugin, but when we are doing our own jars, and we weren't propagating it, so we had to propagate it and take it into account. And then, so these were the relatively easy to solve issues, but then you have all the specificities of the Quarkus build. So the Quarkus build is made of build steps that are methods in the extensions and the core of Quarkus. And these methods, they are gathered, somehow sorted to respect the dependencies of each. So you have basically what we take is that we take the end, what we need as a result, and then we try to figure out a path to come from the beginning to the end. But it's not sorted as in the only thing we wanted was the fact that the dependencies between each task were fine, but we didn't care about the order. So that's one of the parts that I took from Peter, which try to order things a lot better in the build steps. But then, so that the build is not completely slow and problematic, we parallelize all of this. And that's when it becomes more complex, because I cannot be sure that build steps are completely executed in order. I can make sure that the order makes sense and that it's relatively deterministic. But then if I have a task finishing before another, that's life. And this leads to an issue that we are generating a lot of code. Most of the time, this code is reproducible in the way that typically we will generate a hash for a class name, and the hash is deterministic. We will take the parameters or whatever, the name of a method, and get a hash that is reproducible from one build to another. But then there are a couple of things for which we use counters. So you have an incremented counter there, and every time you get a new object of this thing, so typically it has to do with the recording feature that we have in Quarkus. We are able to, during the build steps, we are able to record execution of methods that will be executed either as static init or runtime init when you start your application. And when we record this method, we also record the return value, and we keep a reference to this return value. And to keep a reference of this return value, well, we have a counter somewhere, and each get an ID. But then if you want to be reproducible, it has to be exactly in the same order, because otherwise you will get a different counter for the same code. So here is typically an example of the last hard issue that we have, is that, yeah, you see, in this case, I had the...
Sorry, we're
yeah.
Let me share your screen.
Yeah, sorry.
So is this the diffoscope?
Yes. Yeah. So this is the output from diffoscope, and basically it goes through the application, it goes through the generated bytecode jar, and then it finds a few differences. So what you have to understand is that we came from this situation, meaning that we had all sorts of differences, the file in the zip that weren't exactly sorted in the same way. So that was problematic. Then we had some fields that weren't exactly ordered in the same way. Then we had some bytecode that weren't exactly ordered in the same way. And you had a gazillion. If you have a look at the, well, you had quite a bit of changes. And so you can see the bytecode here, and it's, yeah. And then this is the current situation, meaning that in this occurrence, I was unlucky enough, because I think I had to run this thing 10 times, something like that, to finally get one difference. And we still have cases where things are not exactly executed in the same order because of parallelization.
Yeah. And
then we end up with the counter being not in sync. So in this case, we have 14 instead of 15. And this is because a bit further away, we have this that was actually affected before. So instead of 31, meaning that the code was executed after the block I have seen, we have 14, meaning that the code was generated before, and this is where the difference is. So this is one of the issues that is extremely hard to fix, because you can't, in a lot of cases, what I was saying is that we are using an hash to actually, from the parameters, the name of the method, whatever, and get a hash. Problem is that in this case, when we record things, we can record complex objects, meaning that I don't have an easy way to find a valid way to get a hash. I can't use hash code because most of the time they don't implement hash code, meaning that in this case, I will just get a system hash code, which will be different for each build. I can't use the parameter itself because I have no idea how to figure out a way to to get some sort of hash from this thing. So this is hard, and there are a lot of problematics related to this recording, because we are recording the call, we are recording the parameters, meaning that the parameters passed to recording needs to be recorded in a reproducible way. So we somehow serialize them, but typically if you pass a set, the parameter that we will serialize won't be sorted in a deterministic way, meaning that for any parameter that we pass to the recorder, we somehow need things to be deterministic. So we need them to be deterministic, and then we need our logic, our serialization logic to be deterministic. So that I fixed, and this was a relatively easy fix. But then that means that for each extension out there, we need to make sure that they pass deterministic parameters to our recording infrastructure. And then we will need to find a way somehow to identify what exactly is this call, and find a way to identify it uniquely, ideally without relying on a counter, because we have seen the limits of that. And this is not, this is not something that has been fixed yet. I have tried, so the why it happens not that often is that I have tried to partition the space of the counters. So we used to have a unique counter, and now I have basically a counter per method that is called. So it's a lot better because most of the time the methods are not, basically when you record, you will call the method only in one place, meaning that I record a specific call to, I don't know, I need to register a REST resource for whatever reason. I will register all the REST resources in the same place, which means that given we try to analyze them in order, we will end up with a reproducible calls to the recorder. But for some methods, we are typically this, the factory one here, it's called a lot of time from a lot of places, from various methods. And in this case, partitioning by the method is not enough because you will end up with this issue again. So I'm still not sure how to fix this. We might end up with a workaround at some point for now, until we redesign things or find a future-looking solution. But yeah, for now, I'm skeptical we will be able to do better than find a workaround.
Yeah. We've got a question from Rostislav. He asks, can you achieve reproducible builds with different JDK versions? So putting aside the meta manifest entries like created by.
That's what I hope for, meaning that the JDK implementation shouldn't, basically your contracts should be good enough that the change in the JDK in implementation shouldn't change the output. Now, so you were talking about the manifest. what people are sometimes doing is that either you're basically saying that you will always use this exact same JDK to build, and then for a given version, you will always use this JDK, so you know that your build will be reproducible. But you can also filter the manifest output and say, oh, this one I don't want because I want my build to be reproducible. This could be, you could imagine that, because you can, in the manifest, you can include a ton of things. You can include the name of the machine on which you built. You can include a lot of things. So obviously, if you want your build to be reproducible, you need to filter out this information, or be stricter, meaning that if you build always on the same machine with the same JDK, then you're fine. Also, I mean, if most of your build is reproducible and the only difference is an entry in the manifest, you end up with what I was saying at the beginning, meaning that it's a lot easier to find the difference between the two binaries. So they are not identical, but if you make a diff on both of them, the only difference is the manifest file, and it's obvious, and you don't have to understand what's going on. So but short answer is, the idea is that all the contracts, all the logic should be strict enough that you don't have to be JDK dependent.
It seems like the recorders would make that really hard, though, because I remember Eclipse Java compiler used to produce different bytecode to the default Java compiler, whose name I've just blanked on.
Yeah.
And so then, as soon as you're generating bytecode with the different JVMs, you're potentially sunk.
Yeah. So obviously, if the generated bytecode is not the same, then at some point you
try harder, Guillaume.
Yeah. So that's that's where it gets interesting, because there's our generated bytecode, but then there's potentially changes in the JVM that makes the bytecode different, and in this case, well, you can't fight it. So you need to define your inputs that are necessary to get a reproducible output. I'm pretty sure that, sometimes when you will update the JDK, you will get something different in generated bytecode, and that you can't really fight against. But if your input is stable, you need a fully reproducible output.
Do we see differences between Gradle Quarkus projects and Maven Quarkus projects in terms of how easy it is to achieve reproducibility?
So I would say yes and no. So no, in the sense that the build is working in the exact same way.
Yeah.
So you should have the exact same output. But then there's a catch. For now, the Gradle build is not working exactly in the same way to enforce the timestamp. Typically in Maven, you have this project output build start something. So this is easy. In Gradle, you also have something, and I haven't implemented in the Gradle plugin passing the timestamp information of the build to our machinery. So at some point, the build of the app itself, it's going to be exactly the same, but we need to make sure that both plugins pass the necessary inputs to our build machinery.
Makes sense. So So what comes next?
Yeah, and yeah, one thing I wanted to emphasize also is that so it's not easy, but it's a lot easier because a lot of people already did a lot of work. So the fact that we have the tooling to analyze, Ladislav, one of our colleagues, also did some work on Jambex to make sure that things would be reproducible, both in the generated index, because we include the index in the jar, so we need the index to be reproducible, and also on the output of the index. When you interrogate the index, the answers are reproducible, which is extremely important for us. So we had several breaks already ready for us to start this journey. Not all of them, but at least some of them. So it's yeah, but yeah, really the recorder thing is the last big issue than we have, and yeah, we will have to figure out how to deal with it.
I recommend more showers.
Yeah.
At some point,
definitely,
it's just going to come to you.
walks and showers.
Walks
Yes.
and showers. Yeah.
And talking to David Lloyd also.
Yes. Or a rubber duck if you can't get to David
Yeah.
Lloyd. I mean,
Yeah, but that's
David
the plan.
Lloyd. Sorry, I just wanted to clarify, in case he watches this back, that David Lloyd is significantly more useful than a rubber duck. And I wasn't saying that David Lloyd and rubber ducks were functionally equivalent. But if you can't get David Lloyd.
Yeah, I hope I will get him at some point and be able to. Yeah, I'm pretty sure I will just say that we have to get rid of recorders and do things another way. So, and that's not going to be. We won't be able to do it right now, and so we will have to. Yeah, that's why I was talking about workarounds, meaning that if we can find something acceptable for now, while we have a more better plan for the future, then I think it basically works for me.
Yeah, makes sense. And then, yeah, because then I guess at some point, then it's sort of, if it's too expensive, the solution for reproducible builds, then maybe you then sort of start to go back to that question at the beginning as well of like, okay, well, how much value are we getting from recorders and how much value are we getting from reproducible builds? And of course, if you ask 10 people, you'll get 10 different answers or 20 different answers.
The thing is that we can do without reproducible builds. We can say, oh, we don't care about them, except all of our industry is actually moving to requiring reproducible builds. So just saying, oh, we don't care about them is not an acceptable solution at the moment, and definitely not for the future. We can't do without recorders, or at least something that allows us to do what we are doing at the moment. So we need to find a way to be able to add build time, generate things that will be executed at runtime. We need to find a way to do that. We need to. So even if it's not the current recorder infrastructure, we will need something to replace it.
Yeah.
And what's problematic when you are changing something that is so deep in the core of Quarkus is that close to all extensions are using the recorder infrastructure. So if you change it, that means that you have to adjust all the extensions, all the existing extensions. That takes time, and that's typically not something we will do in one version. If we end up having a replacement for this infrastructure, that means that we will introduce it in parallel to the existing and figure out a way to make it both work at the same time for whatever reason. And then we will have to deprecate it, and then we will have to drop it at some point a lot later. So that's a bit what we did for the config. When we switched to config mapping, it took 10 versions maybe to, maybe a bit more even, to go from we introduce the new infrastructure to we get rid of the old one. So that's something that will take a lot of time. That's why I would very much like to find a workaround for it, even if not perfect, even if not pretty. Yeah.
And I guess another sort of question is, and I think you sort of answered this already, so like, is how much value is there in being like 80% of the way there, 90% of the way there, 9 times in 10 it works? Is that like as good as 0, or is that actually 90% of the value?
Well, the answer is simple. Either you're reproducible or not. So
Yeah.
being 99% there is not useful. It's not good enough. So either we solve the issue entirely or we haven't solved it. But that's typically not something where you can say, oh, I'm 80. It's not an issue where you can say, oh, I solved 80% of it, so it's fine. You need to solve 100% of the issue. Otherwise, you are not reproducible, so you haven't solved the issue. Because if at some point you have to check that your binary hasn't been tampered and it's critical for you, and you run the build and you find you are unlucky enough that you find something that is not the same, you will say, oh, something happened, our binary was changed or whatever, even if it's not the case. So you have to be extra sure, and that's what makes problematic. Not easy because, yeah, usually we like when we can solve 80% of a problem, and then the 20 other percent you say, oh, we'll see. It's not the case here.
Yeah.
And I wanted to go back to the question you were asking about, will it make things better, functionally better? You asked that question. So this is interesting because most of the patches, they go through CI, they pass because they are just ordering things, so they don't change anything really. I mean, you order you sort how the files are added into a jar, so really you don't really care about it. But we have a patch which is one of the foundation of this work, the one from Peter, which orders the build steps. And this one actually triggered CI issues. And so several of them, I didn't have the time to go through all of them, but for at least one of them, it was an actual bug, meaning that we weren't, typically we were registering some vertex handler, and we weren't defining the priority of this handler, meaning that it would have the default priority based on what was added before this handler. So if you change the order, you end up with a different priority for this handler, meaning that it might be executed and it was basically it's a security handler, so you need it executed first, because you don't want to execute the other handler if it fails. And with this patch, we end up with other handler first and the security handler second, meaning that you hit the resource before actually going through the security filter. And so I don't know yet why the order changed, and also why when we were building, we never had the issue. I mean, we never had problematic builds. I mean, on CI, we never had this failing. It's a test, we never had it failing. So somehow it was stable enough until now. But this is an actual bug, meaning that I set hard-coded priority, meaning that this handler has to be executed at this level in this order, and it fixed the issue. And there are a few others that I need to dig. I'm not sure yet if it's an issue with the order we generate, because the order might not be exactly correct, and then thus triggering some bugs. But I would say that if it was incorrect, I would have a lot more failures, given the number of ITs we have, and I would expect a lot more failures. So I need to have a closer look at what's going on. The nice thing is that given we are a lot more reproducible than we used to be, it's a lot easier to compare both applications and try to find out what's going on. So my idea is that I will, I used to have a big patch, because you have to add all of them to be able to get a reproducible build in the end. But several weeks ago, I started extracting the small bits and getting them merged. There are a few pull requests still to merge, but the idea is that I will get everything merged, and then I will generate before, after this, let's reorder things and compare and see what is exactly the difference between both and what makes the thing failing. But that's that's interesting, because I'm pretty sure we will find out a few issues that we didn't have, because, well, the thing is that even if not fully reproducible, the order, and that's what you were saying before, the order was not completely random. It was based on what the data structures we are using were providing to us as a contract, which is loose, meaning that it's not a hard contract, but it's a behavior that is relatively stable, so you don't end up with something entirely random. So changing the order and making the order deterministic actually changed from something that was probably quite stable, not deterministic, but quite stable, to something that is deterministic, but potentially different from what we had before. So that's why we end up with this issue. So that's one of the next steps. There are a few next steps. So the one we talked about a lot is about the recorder, finding a workable workaround for that. There's solving out failures we have in this pull request with the build step order. And once we have that, I think we have something good enough for this very simple REST application that I was testing. But then we have to figure out what's going on for all the other extensions we have out there. So the idea is to have an infrastructure on our CI, checking that all the apps we are generating in our ITs are reproducible. So we will generate 2, 3, 4, 5 of them, I don't know, and compare them across. So we will start with just Linux, I think, And at some point, the idea will be to also compare with Windows, see if we can make the other order stable also on Windows, and maybe macOS also, and see if we can. Maybe we won't be able to, because there might be some very specific differences, and then this will be. I mean, you have a contract for the reproducibility, and as we talked about the GDK version, I mean, the OS might be part of the contract, meaning that if you want the exact same build, you need to use the same OS. We will see how it goes. But that's getting something on CI and getting feedback from CI for all the extension we have out there is part of the next steps. And then we will have to probably set up some tooling, because, as I said, we can't use a Maven artifact plugin because it's only testing artifacts. And our Quarkus app thing is not an artifact. So we might have to develop our own plugin, or maybe tweak it, or contribute to this Maven artifact plugin, I don't know, or make the Quarkus app output an artifact. This is also an option. If you want to test reproducibility, you might have to make it an artifact. We will see how it goes. But it's not something that is finished, and it might not get finished anytime soon. But it started a lot of interesting conversations, I think, across the whole code base. We had to tweak Arc, our CDI implementation, small array config, because small array config generated classes for the config mapping, and it wasn't stable enough. So yeah, our jar files weren't stable enough. So that I think it. And even if we end up with, we miserably failed, still it's the situation is a lot better than it used to be. So even if it's we need 1 year to fix this recorder thing, and we have a far better understanding of where we need to go, of the problematics we need to solve, the issues we have. So even if it's not a win now, it's still a big win. And it's all the work we did also makes comparing things a lot easier, because you don't have a gazillion of differences. You have a few of them. So it makes things a lot better. So, yeah.
Yeah. So, in terms of the binary reproducibility, we may not get there, but in terms of all the other benefits, in terms of stability and fleshing out some of these functional issues, there's definitely an immediate benefit.
We need to get there. So even if it's not now, all the foundation work that we did now is still something we won't have to fix later. And it makes it easier. Typically, if we have to come up with a new recorder infrastructure, and we want to test it's reproducible, the fact that it's the only last piece that is not will make it a lot easier. So it's worth it, really. And I think we should make sure that the part that will be hard is that, if we don't find a way to work around the recorder issue, it means that we won't be able to say we are reproducible enough to include it in our CI, meaning that we won't be able to catch regressions if we get somewhere. So that's why, even if it's not perfect, even if it's ugly, I would very much like to find this workaround, because if we can be in a situation that is good enough that we can test it on CI and make sure we don't have any regression, we are in a far better state for the future.
Yeah, makes sense. Well, we're at time, but it's, really interesting, and yeah, hopefully interesting to others as well to see sort of the journey we're on and why it matters, and some of the interesting challenges that are specific to Quarkus. So I think we don't have any more questions. So I think we can close it there. But yeah, thank you very much, Guillaume.
Thank you.
And best of luck with the recorders.
Yeah.
See you.
See you. Bye.